Picture this. Every single process in the cosmos has been in motion since the beginning. Galaxies race away from each other. Stars burn through their fuel. Planets spin on their axes. Atoms vibrate with thermal energy. And even the fabric of space-time itself stretches outward in an accelerating expansion driven by dark energy. Life on Earth ticks forward with heartbeats, cell divisions, and the slow accumulation of years. And then there's us. We age. We wrinkle. Our bodies break down. We feel time passing in every ache, every memory, every sunset. But what if all that motion, the grand cosmic dance, suddenly stopped? Would time itself grind to a halt? Would we stop aging? Are we growing older only because the universe around us keeps moving? Let's start with something as intimate as your own body. You wake up one morning feeling the usual stiffness in your joints. Gray hairs appear. Wrinkles deepen. Your cells accumulate damage from free radicals and replication errors. Biologically, aging feels like an unstoppable internal clock. But zoom out. That clock runs because chemical reactions happen, molecules bump into each other, energy flows from ordered states to disordered ones. Now imagine the entire universe freezes in place. No expansion, no galactic motion, no atomic vibrations, no heat, no movement whatsoever. Would your body suddenly stop aging? Or would something deeper keep ticking? The question sounds almost philosophical, like something from a late-night dorm room debate or a sci-fi novel. But it touches the deepest foundations of physics, the nature of time, motion, entropy, and whether the universe's grand movements are what make our personal clocks run. Picture a perfectly still universe. No galaxies drifting apart. No stars fusing hydrogen into helium. No planets orbiting. No molecules jiggling with thermal energy. Everything locked in a frozen tableau. In classical Newtonian physics, time was absolute, a universal backdrop that flowed regardless of what happened in it. Clocks ticked the same everywhere, whether objects moved or not. But Einstein shattered that idea. In special relativity, time is relative to motion and gravity. Move fast, and time slows for you compared to a stationary observer. Sit in a strong gravitational field, and time dilates too. Yet even in a motionless universe, local processes could theoretically continue. Here's where it gets fascinating, and a bit unsettling. If the universe truly stopped all motion, including the microscopic jiggling of atoms, then temperature would drop to absolute zero. No kinetic energy means no chemical reactions, no metabolism, no biological processes. Your cells couldn't divide, repair, or break down. Aging, in the everyday sense of wear and tear, would effectively cease because nothing could happen. But is that time stopping? Or is it just everything becoming frozen in a single instant? The real driver of time's arrow, the reason we experience past, present, and future in that order, isn't cosmic expansion or galactic motion. It's entropy. The second law of thermodynamics tells us that in any isolated system, disorder tends to increase over time. A hot cup of coffee cools down as heat spreads out. An egg shatters and scrambles but never spontaneously reassembles. Your body slowly degrades from ordered youthful vitality toward eventual equilibrium with the environment. Entropy provides the arrow, low entropy in the past, the highly ordered state after the Big Bang, increasing entropy toward the future. Cosmic expansion plays a supporting role. As the universe grows larger, it cools, creating more room for entropy to increase. Stars burn out, black holes form and eventually evaporate according to Hawking radiation, and everything trends toward a dilute, uniform, maximum entropy state, the so-called heat death or big freeze. But here's the key point from modern physics. Even if the universe stopped expanding and somehow began contracting, a big crunch scenario, entropy would almost certainly continue to increase. Time would still flow forward. Galaxies would collide, temperatures would rise again, black holes would merge and grow, but disorder would keep climbing. The arrow of time doesn't reverse just because expansion halts. Stephen Hawking once speculated that a contracting universe might run time backward, but later work and consensus lean heavily against that. Entropy keeps marching upward regardless. So, would we stop aging if the universe stopped moving? Not in the way you might think. Your biological aging is a local process driven by local entropy increase, damaged proteins, telomere shortening, mitochondrial dysfunction. Those rely on molecular motion and energy gradients here on Earth, not on distant galaxies flying apart. If the universe's large-scale expansion magically froze but local physics continued, atoms still vibrating, Earth still spinning, sun still shining, you would keep aging normally. Your heart would beat, your food would digest, your cells would accumulate errors. The cosmic backdrop changing speed doesn't directly dial your personal clock. But push the thought experiment further. Suppose stopping the movement of the universe means absolute stillness everywhere. No particle motion, no energy flow, no quantum fluctuations. Then yes, everything halts. Time, in the experiential sense, loses meaning because no events occur. No cause and effect. No before and after in any measurable way. Clocks don't tick because the mechanisms inside them require moving parts. Your body doesn't age because metabolism requires moving molecules. It's like hitting pause on reality itself. But in general relativity, time is intertwined with space-time. A completely static universe might not even be stable or possible given the laws we understand. Einstein himself wrestled with a static universe model and needed a cosmological constant, which later turned out to drive acceleration, to make it work. The universe's expansion does affect how we measure cosmic time. Light from distant galaxies is stretched, redshifted, by the expanding space it travels through, and we observe time dilation in faraway events. Supernovae appear to brighten and fade more slowly than nearby ones. But for us here on Earth, in our local frame, proper time, the time you experience on your wristwatch or in your aging body, marches on independently of the large-scale expansion. The expansion of space between galaxies doesn't stretch the space inside atoms or between you and your coffee cup. Local gravity and motion dominate our daily experience of time. There's a deeper philosophical layer too. Some physicists argue that time itself might be emergent, not fundamental, but arising from the underlying quantum entanglement or the statistical behavior of vast numbers of particles increasing in entropy. In a perfectly still, maximum entropy universe, the heat death far in the future, the arrow of time could blur or disappear because no useful work or change can happen anymore. Everything is in equilibrium. No happening means no clear direction to time. We age because we live in a universe that's still far from equilibrium, with gradients of energy and order that allow processes to unfold irreversibly. So, are we aging due to the universe's movement? Indirectly, yes. The Big Bang set up a low entropy starting point, and the expansion helps the universe evolve toward higher entropy. Without that initial conditions and ongoing cosmic evolution, the arrow of time as we know it might not exist. But your personal aging isn't caused by galaxies receding or dark energy pushing space apart. It's caused by the same thermodynamic arrow playing out in your cells. Ordered systems breaking down into disorder, one irreversible step at a time. Imagine waking up tomorrow and learning that astronomers have detected something impossible. All distant galaxies have stopped receding. Redshifts frozen. The expansion halted. Would you notice any difference in your daily life? Probably not at first. The sun would still rise. Your coffee would still cool. Your body would still feel one day older. Over cosmic timescales, though, the consequences would be profound. No more dilution of matter and energy. Eventually, gravity might pull everything back together if dark energy weakened enough. Stars would burn out without new ones forming easily in a non-expanding sea. But your personal clock? It would keep ticking forward, driven by local entropy, until the far future equilibrium where nothing changes anymore. The strangest part? We humans are the only species, as far as we know, that not only ages but wonders about aging and time itself. We build clocks, write poems about fleeting youth, and launch probes to measure the universe's expansion, all while our own bodies relentlessly demonstrate time's arrow. Whether the universe expands forever toward a cold, empty heat death, eventually contracts in a crunch, or somehow freezes in place, one thing seems robust across scenarios. Time's forward march is tied more tightly to increasing entropy than to any particular pattern of galactic motion. In the end, if the universe stopped moving, our local processes might continue for a while, but in a truly motionless cosmos, everything, including aging, would lose its ability to unfold. Time wouldn't stop in some mystical way. It would simply become irrelevant because nothing would distinguish one moment from the next. We age because the universe is a place of change, gradients, and irreversible processes. Take away all movement, and you take away the stage on which time performs. But here's the comforting or terrifying truth. The universe is still very much in motion. Galaxies fly apart. Stars shine. Your heart beats. Entropy marches on. And so do you, growing older, wiser, and perhaps a little more curious with every passing second in this vast, expanding, relentlessly forward-flowing cosmos. Like and subscribe if you enjoy these long, mind-bending dives into the weird intersections of cosmology, thermodynamics, and what it really means to experience time. Stay curious out there. Keep questioning the clocks, both the ones on your wall and the one ticking inside every cell of your body. And remember, even if the universe's grand movements someday slow or shift, the arrow that truly matters is the one carrying us all from order toward whatever comes next. Your years are still counting up, one irreversible step at a time.